On a clear winter morning, a team of fishermen ventures onto the ice in the footsteps of their ancestors. They're descendants of some of the first people to inhabit one of the world's most extraordinary ecosystems. And while the technology they use may have changed, the method dates back millennia. They bore a line of holes, then pass a long board carrying a rope beneath the ice to stretch 200-foot sections of gill net. When the last is set, the fishermen check a net set the day before. Europeans first came to this place hundreds of miles from the nearest saltwater more than 400 years ago and found native people using gill nets to tap impressive schools of fish. But fish were just one of many natural resources that drew wave after wave of settlers and immigrants here. Men named Astor, Carnegie, Rockefeller, and Ford made their fortunes here. Many more came in search of a better life. Each played a role in transforming the region into the most powerful economic juggernaut the world had ever seen. Because of the nature of this unique place, fish have always played a special role in people's lives, even for people who never think about them. That's because more than 20% of the fresh water on the surface of the planet is here, and that water is fundamental to the health, prosperity, and quality of life of the region's more than 40 million inhabitants. Most of that water flows through 5 giant inland seas known as the Great Lakes. Since French fur traders first came to the Great Lakes region, wave after wave of settlers and immigrants followed. The Great Lakes ecosystem's unique abundance of natural resources fueled a population boom that culminated in the emergence of an industrial powerhouse. The region became the cradle of American consumer capitalism and the arsenal of democracy that helped win 2 world wars. After World War II, something changed. Thanks to high-wage manufacturing jobs and a booming post-war economy, people from all walks of life began coming to the shores of the Great Lakes, not to make money, but to enjoy it. Middle-class prosperity became a ticket to the countryside and a lifestyle that had previously been the sole domain of the well-to-do. They bought boats and campers and built cottages. And like Ernest Hemingway, the Great Lakes native who came to personify the rugged outdoorsman, they went fishing.
This is outdoors country. From the protecting forests tumble clear and sparkling streams. Speckled trout gamely fight and sometimes get away, but most often they end up in the net. Lake trout, often 20 pounds in weight, are another kind of challenge.
People that fished the Great Lakes, especially near big cities, were often disappointed. By the 1960s, a number of native fish species prized by people had disappeared from the lakes, and others were nearly gone. Their absence was a troubling sign.
Fish in general indicate the health of water itself, the quality of water in terms of temperature, chemical composition, toxic substances.
Overfishing was partly responsible. But other human activities also took their toll.
Not only did lumbering clear the land of trees, but it flattened it, it made it smooth, and it made it much more vulnerable to wind and water erosion. The waste products from lumbering were able to enter the rivers and other waterways and to clog the bottoms, to fill up the fish habitat, and to create a sort of sludge along the bottom that had a fundamental impact on the health of the aquatic species in those rivers.
Farming increased the amount of sediment that washed into waterways.
There are some fundamental changes to the quality of the water in terms of suspended sediment and the way that the bottom is shaped and the way the fish are able to spawn.
Wetlands at river mouths that filtered water flowing off the land were destroyed to create harbors. Rivers and streams were dammed to raise their levels for log runs and to power sawmills, grist mills, and eventually hydroelectric plants. The rivers connecting the Great Lakes were dammed and turned into shipping channels, destroying some of the most productive spawning grounds in the lakes and ending natural fluctuations in the levels of Lakes Superior and Ontario.
The Great Lakes, it was basically organized as a vast river. Now, when we came along, we, of course, dammed the tributaries. We dredged out the lower parts of rivers to make ports. We built walls to break the storms near cities, built canals. The effect is to trim the living part off and isolate it, at least to some extent, from the offshore open waters. That was one of the bigger shifts from a moderately riverine kind of system as a living system to a kind of a semi-artificial lake system.
The transformation of the aquatic ecosystem went beyond the physical landscape. Niagara Falls had been an impenetrable barrier between the Great Lakes and the ocean. The opening of the Erie and Welland canals changed that. By 1950, a number of ocean species had migrated into the lakes via the canals. None was more lethal than the sea lamprey. The sea lamprey is an eel-like predator whose mouth works like a suction cup with rows of teeth that attach to fish. Once it latches on, the lamprey bores a hole and feeds on its prey's bodily fluids until the fish dies. No organism native to the Great Lakes feeds on sea lampreys, so there was nothing to stop them.
The larger-bodied fish in the system, lake trout among them, were the ones that were targeted by larger lampreys.
The lake trout fishery once produced and shipped to market as much as 10 million pounds of fish annually.
Lake trout were the natural top-level predator in the Great Lakes ecosystem and a prized commercial and sport fish.
Top-level predators like lake trout, they tend to be much more indicative of the overall health of the ecosystem. So in the cold water systems of North America, the lake trout is the keystone organizing species.
By the 1950s, overfishing and habitat destruction had reduced their numbers significantly. Then sea lamprey overwhelmed what lake trout remained in every Great Lake except Superior.
During its adult life, the lamprey turns into a real vampire, feeding only on the blood and body juices of its victims. Delicate species like trout may be killed in 8 hours. Economic losses have been severe. On Lakes Huron and Michigan, entire fleets have been tied up. Equipment and buildings have been abandoned to the elements.
Lake trout were extirpated from virtually all of the Great Lakes, except for a few isolated parts, embayments on the north side of Lake Huron and in some areas of Lake Superior. In the rest of the Great Lakes, lake trout are gone.
The sea lamprey brought hard times to lakefront towns. Pressure mounted on politicians in the United States and Canada to solve the problem. In the 1950s, more than 400 years after European immigrants first arrived, The first large-scale effort to restore a part of the Great Lakes ecosystem was launched when the U.S. Fish and Wildlife Service declared war on sea lamprey. The trick was to find a way to stop them without further damaging the ecosystem. Fighting adult lampreys in the lakes was impractical, so fishery scientists focused on a more vulnerable stage in their lives. Lewis King was part of the effort.
The whole program is to either keep the adult lampreys out of the streams to spawn, or if they have already created populations of larval lampreys, to find some way to get at these larval populations.
Female sea lamprey lay eggs in stream beds. When the eggs hatch, the larvae burrow into the stream bed where they live for 7 years, feeding on microorganisms before migrating to open water to hunt for fish. Dams were built that blocked sea lamprey from entering streams, but were low enough for spawning fish to jump. But these barriers often failed when stream levels rose during storms and spring runoff. Fishery managers turned to chemicals, hoping to find a compound that would kill sea lamprey without harming other aquatic organisms, especially fish.
The search for the chemical was a long, painstaking affair. We simply tested any chemical that would dissolve in water. Around 7,000 compounds were screened before one group or one family of chemicals was found to be selective to lampreys.
4 years into the effort, researchers found a compound called TFM that showed promise.
Many tests had to be run on this chemical to determine its safety to non-target organisms such as fish, insects, mammals, birds, dairy cattle.
TFM proved to be selectively toxic to sea lamprey larvae in spawning streams. The U.S. and Canadian federal governments formed the Great Lakes Fishery Commission to oversee the use of TFM in more than 200 streams throughout the region.
Within 2 years after those initial applications, their numbers were reduced by about 85 to 89%. So it was shown within a very short time after that chemical went into the field that it was going to work.
TFM made it possible for fishery biologists to tackle the problem of getting fish back into the lakes. In 1965, the Great Lakes Fishery Commission launched the effort to rebuild the lake trout population. Fish hatcheries opened, where eggs taken from adult fish were used to produce offspring that could be released by the thousands into the lakes.
The goal of lake trout restoration, or some would say rehabilitation, is to basically restore self-reproducing populations so that stocking would no longer be needed, and to have those populations support viable fisheries for benefits. The key here is self-sustaining.
But with lake trout largely gone from the lakes, the lack of broodstock proved to be a significant obstacle to restoring something resembling the natural lake trout population.
We're starting from a very, very reduced state of diversity and then trying to rebuild something that was probably tremendously complex and unmeasured.
That wasn't the only problem. By the 1960s, Lake Erie was in serious trouble.
Right now, it's pretty bad. Well, how many dead fish are there out here now? There's 15, maybe 100 if you can't see them all, and all these weeds, and it certainly smells.
So I've seen this place change quite a bit in 69 years. I've seen it so green already that you think you're out in the lake looking down into the green waters of the lake. You think you see it, but it's nothing but just pollution, that's what it is.
30, 40 years ago, you go out fishing. We never carried drinking water. We'd have a cup on a string and we'd reach over and get the water out of the lake. If you do that now, you'd be taking slow poison.
In the summer, 1/4 of the lake is dead, without oxygen. The fish are dying.
As cities grew and more factories opened their doors, the amount of untreated sewage and industrial waste dumped directly into Great Lakes waterways swelled. reaching a crescendo during World War II.
We really were a major part of building the arsenal of democracy, as we called it in World War II. And everything was hurry up and everything was get it done, and very little attention was paid to pollution. The lower lakes, especially from the Detroit River down to through along the Ohio line and onward, it received a lot of untreated waste, some of it pretty bad stuff.
The post-war economic boom prolonged the unchecked dumping of toxic waste.
We used to come out here in Lake Erie and enjoy clean water. Our state's building thousands of dollars, hundreds of thousands of dollars worth of parks along the lake front. And people come out in their cars for a Sunday afternoon recreation period, and what do they got? A cesspool.
Lake Erie is an emblem of gross abuse. There are only a few other parts of the Great Lakes that were abused to an equivalent extent. I think Lake Erie became emblematic of how bad things can be if people are really stupid.
In the 50s and particularly into the 1960s, there was some very serious water quality problems going on, and Canada and the United States asked the International Joint Commission to figure out why was Lake Erie going dead? Why was there massive fish kills on Lake Erie? There were some very significant issues.
The International Joint Commission is an independent, binational organization created in 1909 to resolve disputes between the United States and Canada about the use and quality of boundary waters. With tens of millions of people depending upon the Great Lakes for drinking water, the IJC turned to scientists for answers. Cleaning up the lakes was also crucial to U.S. and Canadian government efforts to restore Great Lakes fish. But that story took a surprising turn when a fisheries biologist made a bold move that focused public attention on the Great Lakes like nothing before. Howard Tanner grew up in Michigan and fell in love with fishing as a child. In 1964, he became Director of Fisheries in the Michigan Department of Conservation and was given a surprising assignment.
I had a director who was a good leader. We had a long conversation, and he ended my conversation with, he said, "Do something. And if you can make it spectacular, why, please make it spectacular."
It was a tall order. Although sea lamprey were being controlled, another aquatic invader was causing big problems in the Great Lakes. The alewife is a prey fish native to the Atlantic Ocean. Like the sea lamprey, it entered the lakes through the Welland Canal and wreaked havoc on the ecosystem.
There were billions of pounds of alewives in the Great Lakes and not much else. They estimated over 90% of the weight of fish in the Great Lakes was alewife.
Now that means that the system was almost all alewives and virtually nothing left. Alewives became so abundant that they probably preyed on the larvae of all other species of fish.
Each spring, each June, each July, alewives would die. There would be a pile of alewives a foot high and 300 miles long, stretching from Chicago to Mackinac City. And they stunk.
But Howard Tanner saw alewives as something more than simply a problem. He had an idea to turn the Great Lakes into a world-class fishing and tourism destination. There was just one problem. There were no fish. Tanner knew that simply restoring lake trout wouldn't help, since they're hard to catch and don't put up much of a fight.
We needed a fish that was high on the scale of desirability as far as the recreational fisherman is concerned, and would provide the excitement to convince people to invest the time and the money that it would take to go out and enjoy a fishery on the Great Lakes. And we had a food supply that was just without limit, and that was the alewife.
Before taking over Michigan's Fisheries Department, Tanner had worked for the Colorado Department of Fisheries, overseeing the stocking of fish in reservoirs there. He got to know fisheries managers throughout the West and became familiar with the region's fish. One afternoon, he received a phone call from a friend.
They said, "Did you know that there's a surplus of coho in the Columbia River?"
Coho salmon were extremely popular with fishermen on the West Coast.
And I realized that there was the tool that we could change the Great Lakes. It was a thrill. I mean, I couldn't contain myself. You want a fish that's big and beautiful and grows fast and eats alewife and is attractive to the sportsman, one that he likes to catch, one that fights well, one that's beautiful, one that tastes good. And I guess you'd have to ask one that's kind of dumb, because after all, you want the fisherman to be capable of outsmarting him and catching him. This opportunity, it's like a ripe plum on a low branch. It's been there, it's right there, but nobody has done anything about it.
The state of Oregon gave Michigan 1 million coho eggs, but it meant introducing another exotic species into the Great Lakes ecosystem. After the disastrous impact of other exotics, Michigan, Wisconsin, and Minnesota had agreed not to introduce exotic species into their waters without a waiver signed by all three.
I was well aware of that compact, but there was not time to honor it. We felt opposition would build if we stalled, and so we said, "Okay, we're bad guys. We're violating the compact, but it's for the good of the cause, and it's going to be all right." So we did it.
The Michigan Fisheries Department also decided to turn history on its head and ban commercial fishing in Michigan's waters to allow salmon to proliferate.
We knew that if we were going to build a sport fishery on the Great Lakes, we were going to have to shut down most of the commercial fishermen, and that wasn't going to be easy. We fought the federal government. They tried to keep us from getting money. They wrote our governor and said veto their appropriations, and they lost.
The first coho salmon raised from Oregon's gift of eggs were released into streams along Lake Michigan's shore on April 2nd, 1966.
There was lots of people. There were reporters, there was my family, there were friends, and then in the afternoon while we had more salmon to plant down in Bear Creek. And so I followed the fish truck down to the Bear Creek, and I planted some salmon there, and it was kind of a special moment. I watched these little fish go down the stream, and they would mature in the fall of 1967.
The following year was one of the worst for alewives. Dead fish littered Lake Michigan's beaches, keeping tourists away and infuriating property owners. When the summer of 1967 turned to fall, a buzz began to develop along the Lake Michigan shore as salmon began returning to the rivers where they'd been released the previous year. Fishermen lined the riverbanks. Then traffic jams choked boat ramps as more and more fishermen arrived to be among the first to hook into what became a fishing frenzy.
The coho fishery just exploded. They called it the Coho Coast. There was a great excitement, and it was declared to be one of the most newsworthy items of the year. And lo and behold, the next year, there was no dead alewife on the beach. People knew the coho had eaten the alewife. And it wasn't true.
The real reason there were no alewives on the beaches was because the previous year's die-off had drastically diminished the population. There were simply far fewer alive to reproduce.
It happened because the alewife ran out of food. And so they came to us and said, "You did it, you solved the alewife problem." And we knew that we didn't have enough fish out there to solve it. And we took credit for it. We must have argued a full minute before we said that. And then not only did we have the support of the people who were interested in the fishing public, we had the support of all those people who wanted the alewife problem solved.
The coho are a smashing success. Salmon are so plentiful that patient anglers who present current 1970 licenses take home some of the surplus fish.
Salmon fever brought people to the Great Lakes like nothing before. Fishing tackle and boat manufacturers introduced products specifically geared to Great Lakes salmon fishing.
Well, if it wasn't for the salmon, there wouldn't be any charter boats in Manistee County or any other county as far as that goes.
The introduction of salmon to this area has meant a great deal to us as business people.
I think the salmon fishing in this area has built up the business at least 50%, motel business and all others.
The frenzy was a culmination of Henry Ford's dream to create an affluent and mobile working class with the money and leisure time to enjoy the outdoors.
It was the leisure time, it was the wealth that followed World War II and the crowding that began to occur in inland waters that clearly demonstrated that the time was ready to convert the commercial fishery to a sport fishery in order to make the most favorable allocation of this vast, vast freshwater resource.
Other Great Lakes states followed Michigan's lead and began stocking salmon, spreading salmon fever throughout the region and beyond, drawing fishermen from around the world. But the boom in sport fishing and tourism shined a bright light on the troubled condition of the lakes. In 1968, a massive die-off of young salmon in Michigan's fish hatcheries was linked to persistent pesticides, primarily DDT, found in waterways where the previous generation of salmon had been released. Water pollution in the Great Lakes was moving beyond simply a matter of public health. It was becoming bad for business, and it was national news. The Cuyahoga River in Cleveland was one of the most polluted rivers in America. In June 1969, the river gained national attention and became a lasting symbol of the deterioration of the Great Lakes when it burst into flames.
The conservation movement did find its roots, its beginnings, perhaps in the late 50s, but principally in the early 60s.
Well, the water used to be a lovely green. You could see it around and never had this here foam and stuff floating around on top of it.
What happens when tourists ask you about it?
Well, I tell them the truth about it because maybe the public will put the pressure on the government and clean some of this filth up.
Public pressure mounted, forcing politicians in Canada and the United States to act.
In 1972, Canada and the United States signed what I think is a revolutionary agreement, the Great Lakes Water Quality Agreement, to reduce nutrient inputs into the Great Lakes and help solve some of the problems, particularly on the lower Great Lakes.
By then, scientists had come to understand the problems plaguing Lake Erie. For more than a century, increasing amounts of fertilizers, animal waste, and raw sewage rich in phosphates had washed off the land or were dumped into the lake. These nutrient-rich pollutants fed an explosion in aquatic plant life. Each summer, tremendous blankets of algae and aquatic plants grew, died, and sank to the bottom. As the plant material decomposed, it sucked the oxygen from the lake, a process called eutrophication.
Then the chemistry changes, and all of a sudden phosphates that had been precipitated out and were tied up in sediments indefinitely became liberated and charged back up, and so this dead zone, at that early kind of a dead zone, brought phosphates back up, and it's a great huge feedback mechanism that got started. And this got started in the 50s.
The initial goal of the cleanup effort was to combat eutrophication. The U.S. and Canada committed massive funding for wastewater treatment plants throughout the region and limited phosphates in laundry detergents.
One of the big contributions of the International Joint Commission, actually going back many years, has been in being sort of a conscience for Canada and the United States in terms of sewage treatment. There was a particular emphasis on bringing sewage treatment up to a minimum standard around the lakes. It had a huge impact.
But that success was tempered by other problems. In 1969, the public learned that fish caught in some parts of the Great Lakes were too contaminated with toxins to eat.
In the war years, there was a tremendous increase in the number of organic chemicals, the range of chemicals that were produced for the war effort, and it's a sort of overly optimistic reliance on the potential for technology to solve all of human problems. One of the outcomes of that industrial activity was very free disposal of the waste of that industrial activity into the lakes and into the surrounding lands.
The pollution from these plants has affected the entire southern end of the lake.
Scientists in the region became aware that there were chemicals that were causing quite disastrous results for fish and wildlife. We had cross-billed cormorants and bald eagles disappearing because of DDT.
From Love Canal, New York, to Hamilton, Ontario, to Duluth, Minnesota, and Gary, Indiana, the price of progress shocked the public as the vast amount of toxic dumping that had occurred came to light.
The character of industry reflects the people who run the industry, and most people are good people. Most industries are good industries, but there are always those that will violate, and the violation was severe.
In their natural state, ecosystems can take care of themselves reasonably well. They can persist a long time even under relatively difficult circumstances if those difficult circumstances come gradually. On the other hand, the way these ecosystems have been affected by us over the last 100, 200 years is very rapid and catastrophic by comparison. Whenever we interfere with these things, the way we've conventionally interfered with these things, it's been harder to live with them. In lots of different ways, they've turned hostile to us.
The Great Lakes Water Quality Agreement was revised to completely ban the dumping of persistent toxic chemicals.
The Great Lakes became a leader globally in terms of addressing these kinds of toxic pollutants.
When we started to look around to see what machinery we had to deal with this situation, we found there was none.
The people are deeply concerned with the environment, that they are prepared to meet the higher costs, both as consumers and as taxpayers, for the programs that really we've got to have and in the Great Lakes Basin ahead of anywhere else.
The pollution of the Great Lakes also prompted Congress to pass the U.S. Clean Water Act in 1972 that included a permit system regulating pollution sources, including industries, municipal governments, and some agricultural facilities.
In the Clean Water Act, the word integrity is specified as a goal, and the intent actually was to bring the waters of the U.S. to a state of integrity by 1985. So they mustn't have had much of a notion about what ecosystem integrity was about if they thought that.
The Great Lakes Water Quality Agreement was revised again in 1978, with the U.S. and Canada committing themselves to restoring, preserving, and maintaining the chemical, biological, and physical integrity of the Great Lakes. The revision also launched a revolutionary approach to solving Great Lakes problems. Rather than tackle problems in isolation, their relationship to the entire ecosystem would be considered.
Some of our most brilliant scientists conceived of the concept of humans as being part of the ecosystem, not separate from it. That the ecosystem approach recognizes the interaction between humans, wildlife, air, land, and water as a cohesive unit, and that anything we do to protect water quality or ecosystem quality needs to look at humans' influence on the ecosystem and all those other physical, chemical, and biological components that comprise the ecosystem.
The struggle to restore the lakes slowly paid off.
We have seen some very good improvements in water quality over the last 25 to 30 years. We've had very good success primarily in the control of point sources. That work is largely accomplished and we're now fine-tuning.
Although water quality improved, decades of unchecked dumping of toxins left large segments of shoreline and lake beds severely contaminated. In the mid-1980s, the International Joint Commission designated 42 locations as areas of concern and launched the Remedial Action Plan Program, or RAP, to clean them up.
Environmental conditions were so severely degraded that some aggressive action needed to be focused specifically on those communities.
Private industry and government agencies funded the removal of millions of tons of sediment contaminated with known carcinogens. But more than 20 years into the program, the results have been largely disappointing.
Only a handful of the Remedial Action Plan sites have actually been removed from the list of RAP sites. And that to me says that in 20 years, more than 20 years of effort, the system is probably not working as well as it should.
The Remedial Action Plan program is just one example of the difficulty in undoing the harm done to the Great Lakes ecosystem over the past 2 centuries. The Spencer Baird is a one-of-a-kind ship. In the spring, she begins making her way through the lakes. Each morning, a fleet of trucks fills her deck tanks with thousands of lake trout fry. After steaming to an offshore reef, she releases her cargo in hopes that they might play a role in establishing a self-sustaining population of the lake's natural top predator. But after more than 40 years of stocking hatchery-raised fish, the goal remains elusive.
We're putting 120,000 fish out today, is it, Dave?
Yeah. Lake trout are very, very vulnerable. They existed and they spawned successfully in those lakes when it was a far different environment. There weren't as many competitors, there weren't as many predators out there. Except in Lake Superior, lake trout are going to have to always be sustained by hatchery planting.
Sea lamprey are still a persistent threat. Although sea lamprey control has diversified, TFM remains the key to having fish in the lakes.
We are in the sea lamprey control game forever. From a basin-wide perspective, if we just walked away from sea lamprey control, they would once again steal away our fisheries. Probably should be thought of as a cost of doing business to have the ecosystem as healthy as we can get it.
Recreational fishing is still big business on the Great Lakes, and since their introduction more than 40 years ago, salmon are still the big draw. Each fall, coho and Chinook salmon return to the streams where they were released to spawn and die. Salmon have adapted well to the Great Lakes, and many reproduce naturally, but except in Lake Superior, natural reproduction doesn't produce enough fish to support the sport fishery. So a portion of the returning fish are herded into weirs, where their eggs are harvested and fertilized, then moved to hatcheries to support the ongoing stocking programs. But things are changing. In some of the Great Lakes, the main food supply, alewives, have dwindled, and so has the salmon fishery. Tom Nalepa is a biologist with NOAA's Great Lakes Environmental Research Lab in Ann Arbor, Michigan. He's aboard the research vessel Lake Guardian to take a series of bottom samples in Lake Michigan. He's looking for a special organism.
This amphipod, the genus is Diaparia, and this is a native species found in the Great Lakes. Fish feed very heavily on them. Probably there's no species of fish found in the Great Lakes that doesn't feed on Diaparia or had fed on Diaparia at some stage in its life cycle.
Diaparia are a key part of the diet of prey fish that lake trout and salmon feed upon, including alewives. But Diaparia have been disappearing from the lakes. That may explain the decline of alewives. But why are Diaparia disappearing? Tom is investigating the links between the disappearance of Diaparia and the spread of two more exotic species. Zebra mussels are filter feeders from the Baltic Sea region of Europe, thought to have hitched a ride to the lakes in the ballast water of cargo ships. They appeared in 1988 and quickly spread through the lakes. Then, an even more prolific invader called the quagga mussel compounded the problem.
We don't see zebra mussels deeper than 50 meters. They just don't have the ability to grow and reproduce at the deeper, colder temperatures that you get in the deeper waters. Quagga mussels can do very well. The numbers are much greater in the lake than we ever saw for zebra mussels. So the ecological changes in response to what all these mussels are doing is going to be much greater in response to quagga mussels compared to zebra mussels.
Some of the most striking evidence of the explosion in quagga mussels can be found on shipwrecks resting deep below the surface. A few years ago, these wrecks, which lie deeper than 50 meters, were free of mussels. Today, they're nearly completely covered.
The lakes are troubled by a whole new set of problems of invasive species that have come in ballast water principally. And they've really modified the biology of the lakes, particularly all of the lakes except Lake Superior. Salmon populations and fish populations in general have declined dramatically in Lake Huron. There's a threat that Lake Michigan will also decline.
Water quality in many parts of the Great Lakes has improved. People now swim at beaches that 40 years ago were covered with dead fish. And native fish, like the lake sturgeon and lake whitefish, are spawning in rivers near industrial areas for the first time in nearly a century.
This fish came from Buffalo, New York, 225 miles all the way across Lake Erie and now up the Detroit River to spawn. Around 1910, there were tens of thousands of these caught in the Detroit River every fall. It was a big commercial fishery, very profitable. And these fish are starting to return to the river now after almost a century of being absent.
In June 2009, President Barack Obama signed the Great Lakes Restoration Initiative, which dedicated $475 million to accomplish the long-term goals of ensuring that the Great Lakes ecosystem is safe and healthy for fish, wildlife, and humans. That means solving existing problems and taking steps to prevent new problems from occurring. One persistent problem has been the contamination of Great Lakes waterways. Wastewater treatment systems played an important role in reducing nutrient loading to the lakes and preventing problems like eutrophication. But many cities surrounding the Great Lakes have what are called combined sewer systems.
Combined sewer systems are just what they sound like. They're a large pipe that takes both rainwater and sanitary flow and combines them in one pipe.
In Milwaukee, that single pipe moves wastewater to the city's Jones Island plant, where it's treated to federal standards and released into Lake Michigan.
Combined sewer system is a really good piece of infrastructure because it protects our Great Lakes from a lot of the pollution that we don't think about, the stormwater pollution. Every once in a while you'll hit a heavy rainstorm and we'll have a combined sewer overflow from that system.
In big storms, the amount of runoff can be much more than the sewer system and treatment plant can handle. When that happens, millions of gallons of wastewater are released untreated into the lake. Like Chicago, Milwaukee draws its water supply from Lake Michigan, so combined sewer overflows threaten drinking water and the city's lakefront parks and beaches. To help prevent contamination problems, Milwaukee built a deep tunnel to help manage overflows.
Prior to this deep tunnel coming online, we had 50 to 60 combined sewer overflows a year. And we had a volume of overflow of around 8 to 9 billion gallons on average, so that was an average flow. And we built the deep tunnel, it came online in '94, and almost immediately we dropped the overflow volume and numbers. Since it's been operational for the last 14 years, we're averaging about 2 overflows, combined sewer overflows per year. Where we had 50, we're down to 2. And where we had 8 to 9 billion gallons, we still have overflows, but it's around 1 billion.
Combined sewer overflows are a persistent problem throughout the Great Lakes region. Chicago and Toronto have also built overflow tunnels, and more cities are considering them. Restoring and maintaining the biological and chemical integrity of the Great Lakes continues to be a significant challenge. So does restoring and maintaining their physical integrity. Fresh water, the Great Lakes' defining resource, is becoming an increasingly scarce and valuable commodity around the world. Climate change threatens the water supplies of more and more people and increases pressure to tap into the most abundant concentration of fresh water on the surface of the planet. Proposals have been made to export Great Lakes water outside the region. In response, the governors of the 8 Great Lakes states and premiers of the 2 Canadian provinces signed the Great Lakes Charter, formalizing their commitment to refuse permits to anyone seeking to divert Great Lakes water outside of the basin. In 2008, that commitment was sealed by the Great Lakes St. Lawrence River Basin Water Resources Compact, which was signed into law by President George W. Bush.
One of the concerns was to prevent large-scale diversions from the Great Lakes, so the governors needed to enact some type of legislation to protect them from that. There was no consistency in the way the laws were being applied before the compact.
But topography has presented some communities with a frustrating dilemma. Waukesha, Wisconsin is a quiet bedroom suburb of Milwaukee, a 15-minute drive from Lake Michigan.
Waukesha has been a city since 1896. Its claim to fame was in 1868. Colonel Dunbar, who was seriously ill, came and drank out of the Bethesda spring and was miraculously healed. And this started a period from the 1870s to the early 1900s where Waukesha's nickname was the Saratoga of the West. We had beautiful hotels and spring houses.
Waukesha's abundant groundwater came from an aquifer that runs along the southwestern shore of Lake Michigan.
The deep sandstone aquifer is being depleted. Water's being pumped out of it about, on a regional scale here, about 2 to 3 times faster than it would have been naturally replenished under natural conditions.
But that's not Waukesha's biggest problem.
What is prompting them to look to alternative sources right now is radium. The EPA has now required that they have to meet the current radium standard in drinking water, and several of their wells don't meet it. So the radium has to be removed, and that's a fairly expensive process.
Radium is a naturally occurring substance toxic to humans. Faced with the prospect of running out of usable drinking water, Waukesha looked to the Great Lake just 15 miles away.
It's crucial for the health of our city that we make sure our residents have safe water and that we have a source of water that will help us grow and continue to be a vibrant, exciting city like we are today.
But there was a problem. Waukesha lies 1 mile outside the Great Lakes drainage basin, so technically it wasn't eligible to access Great Lakes water. Because of Waukesha and communities like it, the Water Compact includes provisions for what are termed straddling communities to apply for Great Lakes water. Waukesha became the test case for the provision.
The biggest obstacle that we faced was not setting a precedent where you would be opening up the doors for anyone in western United States or southern United States to have access to the water. What we needed to do was work with a lot of different groups that looked at how we could create an application that would set the bar high so that when somebody else wanted to apply, they would have to meet the same criteria that we had to meet.
One of the key elements of the compact is the requirement that any water drawn from the Great Lakes be replaced with an equal amount of treated wastewater. Right now, Waukesha releases wastewater into the Fox River, which runs through town. But the river flows towards the Mississippi River, not the Great Lakes, so Waukesha faces the expensive prospect of reconfiguring its wastewater system. It remains to be seen how Waukesha's experience will influence other efforts to divert water from the Great Lakes.
We have water issues within our basin. They may not be as extreme as they are in western United States or southern United States at this point, but some point down the road they will be that extreme. How do we address this, and how do we make sure the Great Lakes is here and sustainable for the long term, for the generations to come? That it's not something that deteriorates and is depleted to a point where it's not usable anymore.
The Great Lakes Compact can be a model for other parts of America as well as other parts of the world that are really struggling how to solve water problems in the 21st century.
Fresh water is the defining element in the Great Lakes ecosystem. Nowhere on Earth is there a greater concentration, and that water has played an outsized role in determining the fortunes of people here throughout history. The indigenous people that first populated the region invented ways to survive, learning to navigate the lakes and rivers and use the abundant natural resources. Native people shared that knowledge with Europeans, whose descendants harvested the region's fur animals to near extinction while spreading European civilization across a large portion of the continent. More immigrants came, drawn by stories of limitless natural resources free for the taking. Rich soil fit for tilling, forests filled with timber, and rich veins of copper, iron, and nickel drew speculators keen on making fortunes and laborers seeking better lives. Their rewards financed the transformation of the region's rivers and shorelines, making the Great Lakes into a maritime highway that carried unprecedented quantities of raw materials, fueling the emergence of the most powerful manufacturing center in the world.
Those great agricultural and industrial enterprises that really built America and Canada and powered our agro and industrial revolution were all created here in the Great Lakes region. The auto industry, aviation industry, the chemical industry, and so much more really defined the economic might and created tremendous wealth, tremendous jobs, and tremendous economic opportunity. The water was so critical to that as a key input into making really the industrial revolution, which was centered around the Great Lakes.
Lake steamers still fill their holds with iron ore at ports near the Minnesota and Michigan iron ranges. But their cargo doesn't feed factories in Detroit or other Great Lakes cities like it used to. A new chapter in the history of the relationship between people and the Great Lakes ecosystem is being written, and no one is certain how it might end.
With globalization, with new markets opened up worldwide, new competition, some of the great products that we invented here in the Great Lakes, from our steel industry to our auto industry, came under new foreign competitions.
Like the fur, timber, and copper mining industries before it, the glory days of heavy manufacturing are fading into history. Millions of manufacturing jobs have moved overseas, forcing the Great Lakes region to adapt to new realities in the 21st century. Communities are struggling, and young people raised and educated here are seeking opportunities elsewhere.
That's another particular challenge for us in our region, is to make ourselves an attractive place that people want to stay, as well as create a more diverse set of employment opportunities beyond the auto and heavy industry that sort of is our reputation and defines us.
The success in making that transition may once again depend upon the Great Lakes themselves.
We've got to leverage unique assets we do have. Today, water matters most powerfully to the economy, not as a conduit, not as an input, but as a sort of amenity, as a place definer. Our water now is more important to our economy as a place that makes us a choice location for people to live, work, and do their business.
But capitalizing on the Great Lakes in the new economy will require confronting the legacy of the old.
We made a big mess inventing the Industrial Revolution. We have more brownfields and polluted industrial land. We have more toxic hot spots in our rivers and lakes historically and currently than other parts of the country. We've got a lot of cleanup to do of our waterfronts. We've got to make sure our Great Lakes are available for enjoyment, for swimming, for boating. If the beaches are closed during the summer, it doesn't leverage this incredible and spectacular natural asset that we have.
The Great Lakes region is an environmental asset and it's an economic asset. and one is integrated with the other. They are inseparable. In order to maintain the quality of life that we have in the Great Lakes and the output, the economic output of the Great Lakes, we have to have good environmental quality.
We've got a spectacular freshwater coast here. Anyone who's been around or seen the Great Lakes appreciates their majesty, their grandeur, their vital power to transport you away from your day-to-day life. So if anything, the magical property of living, working, and seeing and being near the water that we have is as valuable or more valuable than any of our other economic assets.